All right, so we're gonna go back to solving oblique triangles. So remember, an oblique triangle is any triangle that's not a right triangle. And to solve an oblique triangle, right, that means finding all the angles and all the side lengths. In order to solve, we need to know one side length and two additional pieces of information, okay? So here we know a side length and two angles. Same thing here, side length and two angles. So I've grouped those together as one case. Here we know a side length, an angle, and another side length. Here we know a side length and two other side lengths. And here we know a side length, and an angle. Okay, so these are the four cases for solving oblique triangles. Each one uses a slightly different technique to solve, but in each case, our goal is to find all of the angles and all of the side lengths. Okay, so we're gonna go through each one. So side angle, angle, or angle, side angle, the technique is the same for solving. So I'm gonna kind of group them together. So what are we going to do? Well, if I sketch a picture of this, and I'm not gonna sketch this to scale, I'm just gonna kind of sketch a general ABC triangle to help me see what I know and what I don't. So A, B, C, what do I know? I know that my B is 87 degrees. I know my C is 42 degrees. I don't know my A, but I know side length A is 18.9. I also still need to find side length C and side length B, okay? All right, well, one of these things is really easy to find. What's really easy to find here? Well, I think I can find angle A pretty easily, right? Angle A I can find using the fact that the sum of the angles of a triangle is 180 degrees. So if I do 180 minus 42 minus 87, that tells me that angle A has to be 51 degrees, okay? Now that I know all of the angles of my triangle, I can use my law of sines to figure out side length B and side length C. So remember that the law of sines says sine of A over A equals sine of B over B equals sine of C over C. So if I want to say solve for side length B, well, I can set up the ratio that says sine of A over A. So sine of 51 degrees over 18.9 is going to equal sine of B, sine of 87 over the thing I want to know, B. Okay, now I'm just going to solve this. Multiplying both sides by B gives me B times sine of 51 over 18.9 equals sine of 87. Then I can multiply by 18.9 and divide by sine of 51. So B is going to equal 18.9 sine of 87 degrees over sine of 51 degrees. Okay. Some people prefer to cross multiply. If you cross multiply, you'll get B sine of 51 equals 18.9 sine of 8.7. Dividing by sine of 51 gets you to here. And now we're going to use our calculator. Make sure your calculator is in degrees. Okay. And we do 18.9 sine of 87 divided by sine of 51. And that is 24.286. Let's go ahead and round to the nearest tenth. So we'll call that 24.3. So B is 24.3. We now need to find C. We could use a law of cosines to find C, but honestly, I think law of sines is easier to work with. So I'm going to just use law of sines again. Now I'm going to use the fact that sine of A over A is equal to sine of C over C. So that tells me that, again, sine of 51 degrees over 18.9 equals sine of C, sine of 42 degrees over C. The only thing I don't know there is C. I can solve for C by cross multiplying, however you want to solve for C. By cross multiply, I get C times sine of 51 equals 18.9 sine of 42. Dividing by sine of 51 lets me solve for C. Plugging this into my calculator, 18.9 times sine of 42 divided by sine of 51 gives me 16.27. Rounding to the nearest tenth would be 16.3. So C is 16.3. We now know all the angle measures and all the side lengths, so we've completely solved this triangle. Let's look at the next one. All right, So now we're going to solve a side angle side. So again, I'm just going to sketch a general triangle, and it's not to scale. In fact, I know it's not because it should be an oblique triangle with 124 degrees, and it's not, but that's okay. It's really just helping me keep track of what I know and what I don't know. So what do I know? I know that angle B is 124 degrees. I don't know angle A. I don't know angle C. I know that side C is equal to 20, and I know that side A is equal to 15. Okay, so how are we going to go about solving this? We can't use our trick from the last one of finding, excuse me, of finding our angles using the fact that the sum of the angles of a triangle is 180, at least not yet. We need 2 angles to do that. So what can we do? Well, the easiest thing to do right now is to figure out our third side. And we can figure out the third side using the law of cosines. So law of cosines is kind of like a Pythagorean. Hi, Max, say hi and then go, please. Hello. Okay, now go play. Thank you, baby. So law of cosines is sort of like the Pythagorean theorem for oblique triangles. So in this case, we want the law of cosines that lets us solve for B. So that says that B squared is equal to A squared plus C squared minus 2A times C cosine of B. Okay, all right, so let's start plugging in. We don't know B squared, that's what we're trying to solve. We know our A is 15, so we'll have 15 squared plus, we know our C is 20, 20 squared minus 2 times 20 times 15 times cosine of, we know our B, 124. Okay, so notice now, the only thing we don't know is our B, so we're just going to kind of plug and chug from here. So 15 squared, I believe, is 225. Let me check that. So 15 squared is 225. 20 squared is 400 minus 2 times 20 times 15 is 600. I'm going to go ahead and do 600 times cosine of 124 to get a decimal approximation. 124, cosine of 124. I am in degrees. So that gives me negative 335.5 with a little bit of rounding. So 225 plus 400 plus 335.5 gives me 960.5. So B squared is equal to 960.5. Square rooting that gives me B equals 30.99, which if I'm rounding to the nearest tenth is going to round to 31. So now we know our B is 31. Okay, now let's figure out either our A or our C. We can figure out A or C using the law of sines. So law of sines, I can say something like sine of B over B equals sine of A over A. So that says sine of 124 over 31 equals sine of A over 15. Okay, multiplying both sides by 15 gives me 15 sine of 124 over 31 equals sine of A. I'm going to go ahead and get a decimal approximation for that left-hand side. 15 sine of 124 divided by 31 is 0.388. So 0.388 equals sine of A. I'm going to use inverse sine. So inverse sine of 0.388 tells me that A equals 22.8 degrees. Okay. So now I know my A is 22.8 degrees. I could use law of sines again and do something like sine of B over B equals sine of C over C. But at this point, I know two of the three angles of my triangle. So I'm just going to use the fact that the angles of a triangle sum to 180 and do 180 minus 124 minus 22.8 to get our last angle is 33.2 degrees. So there we go. We use law of sines and law of cosines in this one. So law of cosine first and then law of sines. And then the fact that the angles of a triangle sum to 180. And now we have completely solved this triangle as well. All right, let's look at a side, side, side example. All right, side, side, side. So again, I'm just gonna sketch triangle. Don't really know what it looks like. Don't really care. Just need some labeling. I'm gonna call this A, B, and C. Side A is 9. Side C is 7. Side B is 5. Okay. So we know all 3 sides, but we don't know any of the angles. We're gonna have to use law of cosines here. Okay. So law of cosines, take any flavor you want. I'm going to go ahead and do the flavor that says c squared equals a squared plus b squared minus 2ab cosine of c. Okay. Notice here, I know c, I know a and b, no a and b. The only thing I don't know is the measure of angle c. This is going to let me figure out the measure of angle c. Okay. All right. So let's start plugging in. C squared is 7 squared, which is 49. A squared is 9 squared, which is 81. B squared is 5 squared, which is 25. Minus 2 times 9 times 5 times cosine of c. All right, so we're trying to solve for cosine of c. I'm going to go ahead and subtract 81 from both sides and subtract 25 from both sides. So that's going to give me, let's see, 49 minus 81 minus 25 is negative 57. So negative 57 equals 2 times 9 times 5. 2 times 9 times 5 is 90. So negative 57 equals negative 90 cosine of c. Dividing both sides by negative 90 gives me 57 90ths equals cosine of c. So I'm going to use an inverse cosine. So cosine inverse of 57 over 90 is going to be equal to c. Excuse me. So inverse cosine of 57 90ths gives me 50.7035. So I'm going to round that to, I already forgot, 50.7 degrees. So now we know that our C is 50.7 degrees, okay? At this point, we have 2 choices, okay? We could do law of cosines again, picking a different side. So I could say use the b squared equals a squared plus c squared minus 2ac times cosine of b to get b. I personally think law of sines is slightly easier to work with. So at this point, I can get angle b using a law of sines, right? Law of sines says sine of c over c equals sine of b over b. I know big angle c, I know side c, I know side b. The only thing I won't know is angle b here. So that means sine of 50.7 divided by 7 equals sine of b over 5. Multiplying both sides by 5 gives me 5 sine of 50.7 over 7 equals sine of b. Okay, I'm going to go ahead and get a decimal on this left-hand side. So 5 sine of 50.7 divided by 7 gives me 0.55. So 0.55 equals sine of b. Doing inverse sine, so sine inverse of 0.55 is going to equal b. So sine inverse of 0.55 gives me b equals 33.4 degrees. So 33.4 degrees is my b. Okay, so b is 33.4 degrees. Last, I know 2 of the 3 angles of my triangle, so I'm going to use the fact that the sum of the angles of a triangle sum to 180 to do 180 minus 50.7 minus 33.4. To get my last angle must be 95.9. Okay, so we use both law of cosines and law of sines, and we fully solved that side, side, side triangle. Last, we're going to look at the most challenging case, side, side angle. This is known as the ambiguous case. So this is the case where we could have 0 answers, 1 answer, or 2 answers. All right, so our last case, I'm again going to just sketch the triangle. This is just a sketch. It's just helping me label and figure out what I know and what I don't. So I know my angle B is 31 degrees. I know my side A is 13, and I know side B is 8. Okay, all right. So remember that this is the case where we could have more than one solution. Okay, so this is the ambiguous case. This is the case where there could be 0 triangles, there could be 1 triangle, or there could be 2 triangles. In our solving, we need to identify which case this is, as well as solve this triangle. Okay? So thank you, Piper. When we're dealing with these, okay, let's go ahead and start with a law of sines to find one of the other angles. Okay? This will also tell us if we're in the 0 case, the 1 case, or the 2 triangle case. Okay? So here we go. Law of sines. I know angle B. So I'm going to do something like sine of B over B equals, it doesn't matter which of these angles you solve for, A or C. I'm going to do A. Sine of A over 13. Okay? All right. So, sorry. Sine of B over B equals sine of A over A. Now we're going to plug in our numbers. We know that B is 31 degrees. We know that side B has length 8. We're looking for angle A. We know that side A has length 13. Okay? So I'm going to multiply both sides by 13. I get 13 times sine of 31 over 8 equals sine of A. Okay? So let's go ahead and get a decimal approximation. 13 sine of 31 divided by 8 is 0.8369. I'm going to round that to 0.84. Okay? Okay, here is the good news. We have eliminated the 0 triangle case right here. Why? Because this is between -1 and 1. In other words, this has a solution. Remember that sine goes from -1 to 1. That's its range. It cycles from -1 to 1, -1 to 1. If this number is bigger than 1 or smaller than -1, we're in the 0 triangle case. Okay? The good news is if you go to your calculator to put the 0 triangle case in, so you do inverse sine of both sides, your calculator is going to give you an error. That means you're in the 0 triangle case. Okay? So we're not in the 0 triangle case. This makes a triangle. In fact, it may make 2 triangles. To figure out if it makes 2 triangles, we're going to keep going. Okay? To keep going, what do? We do inverse sine of both sides. I need that marker. Here, can you have this marker? Here, that marker. Okay, here you go. Here you go. Okay, we're going to do inverse sine of both sides. So sine inverse of 0.84 equals A. And let's go ahead and put that into the calculator. Okay? Inverse sine of 0.84 gives me 57.1 degrees. Okay? So I get A equals 57.1 degrees. Okay, so we know that we have one triangle that satisfies this. I'm going to sketch that triangle here. Okay, again, this is just a sketch. I don't care what my angle sizes actually are. So I know when A is 57.1 degrees and B is 31 degrees, there's one triangle that solves this. Now looking at this, I can quickly find my angle C. Angle C will be 180 minus 31 minus 57.1. So our angle C is 91.9 degrees. Okay. So this is one triangle that solves our initial conditions. I need to finish solving this triangle. Okay. In other words, I still need to find C here. Before I do that, I want to think about, is there another triangle that solves this? To answer if there is another triangle that solves this, okay, you're going to take this A that you calculated, and you're going to look at the supplement. So I'm going to do 180 minus 57.1. Okay, that's 122.9. If there is another triangle, it would have this angle A. So the question is, can I make another triangle? And again, I'm not drawing this triangle to scale. I'm just trying to think about what is what. I know that B is 31. My potential A is 122.9. Again, I got that by finding the supplement to this original table that I found. And then the question is, can this make a triangle? Is there enough to actually make an angle C? So I do 180 minus 31 minus 122.9, and that gives me 26.1. So we are in the two triangle case. In other words, here is the other triangle that I need to solve, okay? In this triangle, B is still 8, A is still 13, so I need to find C in both of these cases to fully solve this example of side-side angle, okay? Now, if there was only one triangle, what would happen? When you found the supplement and tried to make another triangle, it would not work. You would not have any degrees left over to make angle C, okay? In other words, you wouldn't get a triangle by summing your degree angles to 180. In this case, we did. We're in the two triangle case. So I have to finish solving by finding C twice. I need to find C once in this triangle, and I also need to find C in this triangle, okay? Both of those I can use a law of sines. You could also use a law of cosines. I'm more of a fan of the law of sines, so I'm going to use law of sines for both. If I want to find C using law of sines, I can use the fact that sine of C over C equals sine of B over B. What do I know? I know my angle C is 91.9 degrees. I know my angle B is 31 degrees. And I know my side B is 8. The only thing I don't know is side C. If I do a little cross multiplying, I get 8 sine of 91.9 equals C sine of 31. Dividing both sides by sine of 31 gives me C equals 8 sine of 91.9 over sine of 31. Putting that into my calculator gives me 8 sine of 91.9 divided by sine of 31, 15.5. So here we get C equals 15.5. So our C equals 15.5. Now let's solve the other triangle. Okay, solving the other triangle we got in this case, I'm going to solve it exactly the same way. I'm going to use sine of C over C equals sine of B over B. Here, my C is 26.1. My little angle C is what I'm looking for. B is still 31. Side B is still 8. Cross multiplying gives me 8 sine of 26.1 equals C times sine of 31. Dividing both sides by sine of 31, I get C equals 8 sine of 26.1 over sine of 31. Plugging that into my calculator. 8 sine of 26.1 divided by sine of 31. I get C equals 6.8 in this case. Okay, so now we've solved the second triangle, 6.8. Notice that both of these are triangles that work based on our initial 31 degrees, 13, and 8. 31 degrees, 13, and 8. Both of these triangles are solutions to this side-side angle case, okay? Side-side angle is the only case where we have the possibility of 0 triangles, 1 triangle, or 2 triangles. All right, there we've looked at all of the ways we can solve oblique triangles.